the rate constant for a first order reaction is 60 second inverse. How much time it will take to reduce the concentration of the reactant 1/10 of its initial value? So calculate the time to 1/10, that is log of a by a minus x. So a minus x will be a by 10. Calculate it. Do it. Asmita, Akash, Subhojit. You can do it. So k is given and k equal to 2.303 by t half log of a by a minus x. Now putting in this formula, you can do it. Calculate and tell me the answer of the problem. Tell me the answer of the problem. Very simple. Are you doing? Because it is second inverse, so when it would be lower, the unit will be in second. 1.7 into 10 to the power minus 2 is this. There is no answer given. Subhojit, what is the unit of T half? The half life period. What is the unit of half life period? .8 into 10 to the power minus 2, not 1.7. 2.3 by 6 into 10. If this calculated, then 2.3 divided by 60. .038. Yes, it is 3.8 into 10 to the power minus 2 second. It's not 1.7. 2.3 divided by 6, this is near about 0.38, isn't it? Okay, next one. This is 3.8 into 10 to the power minus 2. Next, the rate constant of a reaction with respect to reactant A is 6 minute inverse. If we start with the concentration of A, that is 0.8 mole liter inverse, when would concentration of A reach the value of 0.08 mole inverse? Okay. Now, the rate constant of a reaction with respect to A, rate constant, that is K, with respect to A is 6 minute inverse. Okay. And if you start with, that is initial concentration of A, that is equal to 0.8 mole liter inverse. When would concentration of A reach the value of 0.08? So, concentration of A final of this is equal to 0.08. Now, it is 1/10 again. Ka is given with respect to A. Now, you have to calculate the time. So, T equal to 2.303 by K log of A by A minus X. Now, A by A minus X, this is equal to 10. 2.303 by K, K equal to 6 minute inverse. Log of A minus X, this is equal to log 10. Log 10, that is 1. So, 2.303 by 6 minute. 2.303 by 6 is equal to 0.38 minute. So, when it would reach the concentration, that is at the time 0.38 minute. Next problem. Yes, 138 minute inverse or minute. How many minute? Yes. Next one. Understood, Subhajit? Where are you? The initial concentration of N2O5 in the following first order reaction, N2O5 to 2NO2 plus N2O5 2NO2 2N2O5, I think 2NO2 gas plus half of O 4 5 2N was the initial concentration of N2O5 in the following first order reaction was the concentration of N2O5 was 1.24 into 10 to the power minus 2 mole liter inverse. At 318 K, the concentration of N2O5 after 60 minutes was 0.20 into 10 to the power minus 2 mole liter inverse. This is at T60. This is T initial. Calculate the rate constant for the reaction at 31.8 K. Calculate the rate constant at 31.8 K. The previously it is mentioned at 318 K. So, how to calculate it? So, K equal to, as the first order equation, 2.303 by T A by A minus x. Now, here A equal to is given 1.24 and A minus x equal to 0.20 and T is T60. So, here it is it can be calculated. It is not 31.8, it is the finally you have to calculate it at 318 K. 318 K, simple one. So, K equal to 2.303, T equal to 60. After 60, yes, so log of A by A minus x 1.24 into 0.20. So, 2.303 by 60 log of 0.20, that is 20 and 24, 6, near about 6 point something or near about 6. So, log 6, log 2 into log 3, it is equal to 0.79. So, 2.303 into 0.79 divided by 60. So, answer is 0.03 minute inverse, because it is in minute. So, it would be minute inverse 0.03. A first order reaction is 50% complete in 25 minutes. Calculate the time for completion of 80% of the reaction. First order is 50% complete in 25 minutes. So, K equal to 2.303 by T log of half, that is A by A minus x. 50% completes, that is it is 50, A minus x it is 100. So, 2.303 and the time is 25 minute log 2. So, this is the value of so from there K can be log 2, that is 0.3. So, 2.303 into 0.3 by 25, it is about 0.0277 minute inverse. Now, the time required for 80% complete of the reaction. Now, T equal to 2.303 by K log of 80% complete. So, A equal to 100 and A minus x equal to 20. A minus x 80% complete. So, it is equal to 2.303 by 0.0277 log 5. Now, this will give the value of near about 58.11. 58.11 minute. This is the required formula. Simple. This type of math are usually to come. In the same way, a first order reaction is 20% complete in 10 minutes. Calculate the time for the completion of 75% of the reaction. This question came on the exam CBSE 2017 and on the okay, so very important this type of question, this type of problems basically. Okay, now coming to one pressure type question, that is when the reactants are gaseous in nature. Okay, so for this one equation to be written, 2N2O5 2NO2 plus O2, all are in gaseous state. Okay, and when the time is 0, T equal to 0, then the total pressure P total equal to 0.5 atmosphere. Pressure is equal to 0.5, and the time when 100, the T equal to 100 any unit, then it becomes the total pressure equal to 0.512. Okay, this is given. Calculate the rate constant for the gaseous reaction. Calculate rate constant K, you have to find out. So as this is in gaseous state, so for this we have to derive the equation in the gaseous terms. So when T equal to 0, the total pressure is given. When T equal to 100, the total pressure is given, and the equation is N2O5 equal to NO2 plus O2. Now 2N2O5 to 2NO2 plus O2. P initial. Okay, so P initial, that is it was 0.5 molar, 0.5 atmosphere. It is 0. It is 0. And after the time, that is after 60 minutes, 100 second or 100, it becomes less, that is 0.512. Let us assume that only x per mole. So x is the part which is dissociated. So after, that is P T equal to 100, where it is equal to 0.5 minus 2x. This is 2x and this is x. So Pt equal to 0.5 minus 2x plus 2x plus x. This is equal to 0.5 plus x, because this is cancels out. So this is the total pressure at this time, that is at time 100 s. Pt minus point. So x equal to, so from here x equal to Pt minus 0.5 atmosphere. This x is the x of A by A minus x. This x is calculated, A by A minus x. Now, so P2 pressure of N2O5, pressure of N2O5 equal to now we will put the value, that is 0.5 minus 0.5, which was initial, minus 2 into x. Now x equal to Pt minus 0.5. So Pt is equal to, which was the Pt? Pt equal to 0.512. This is equal to 0.512 minus 0.5. So this is equal to 0.012. So 0.5 minus 0.12 equal to 0.0024. It is equal to 0.026. P of N2O5 equal to 0.026. Okay, I missed here. No problem. Oh, sorry, this is not that. It is equal to 0.5 minus 0.024. So 637.4, 0.476. This is equal to 0.476 pt, that is P of N2O5. Now K equal to 2.303 by T log of Pi by Pa. 2.303 by T log of Pi. Initially it was 0.5 and this is the final 0.476. So T point, and what is the time? That is 100 s. So 2.303 by 100 log of this value 0.5 by 0.476. This is about 1.0504. So this beta is 4.91 into 10 to the power minus 4. 2.303 by 100 into log 1. Log 1 log of 1.05, 0.021, 0.021. So ultimately it becomes 4.9 into 10 to the power minus 4. Very important problem, this one. 3 marks, second inverse. Okay, this such type of problem we have done today. 3 kinds of problem: gaseous, using the half lives, and the first two examples also different. Okay, so this type of problems are usually to come. This is 2.4 into 10 to the power minus 5. Is it? No, Akash. If we multiply it, these two data, then it would be 0.048. These two data will be 0.048 divided by 100. So it is 0.00048. So if you multiply 100, then 4.8 into 10 to the power minus 4. So this is the correct one. No, it is not a zero order. This is the first order reaction because we are using this equation Pt equal to log of A by A minus X. So this is a first order reaction. Okay, so that's all for today. Thank you.